Welcome you all back to my YouTube channel. So if you are new to this YouTube channel, consider subscribing so that each time I upload a new content, you get to be notified. And in this lesson, we are going to talk about wave motion. We are going to talk about properties of a wave with exam questions. This lesson is good for the grade 10 to 12, even the GCEs. It is good for your revisions because we are going to take some exam questions as examples. So, a wave is the form that some type of energy take as they move. This is the definition of a wave. This is what you need to understand about a wave. So some book gets to define a wave as the disturbance that occur on the surface of an object. So if, let's say, this is an object, let's just say this is an object. So this is a disturbance that occur on the surface of an object. So it can be on this point, it can be on this point, or any other point. So this is just a disturbance that is occurring on the surface of an object, and it is able to transfer energy. So it is able to transfer what? It is able to transfer energy from this point to the other point. So this is what you need to get. So energy is being transferred from this point, from a point where this disturbance is occurring from, to the other point. So now we've got examples of these waves. The first example that we can have a water wave. Have you seen? So as those water waves are taking place, the disturbance is occurring on the surface of the waters, and they are able to transfer energy from one point to the other point. We've got a sound wave. So these are examples that I want you to understand. We've got a sound wave. So we've got a sound wave. So this is also an example. You are able to call someone from Lusaka when you are in the copper belt. So which means that waves are able to vibrate from copper belt to Lusaka. Have you seen? So this is what you need to understand. So these are just examples. We've got light waves. So we've got light waves. Have you seen? All these are examples. We've got electromagnetic waves. All these are examples of a wave. So you need to understand all these things. Now, in general, what I'm trying to talk about is that there are two types of waves. So there are only two types of waves. There are only two types of waves that you need to understand. Two types of what? Two types of waves. So all these that I've listed here, we've got the water wave, we've got the sound wave, we've got the light wave, we've got the electromagnetic waves. All those can be categorized in two types. So the first type that we are going to talk about is called a transverse wave. This is the first type that we are going to talk about. It is called a transverse wave. So now, what is a transverse wave? What do you understand when we talk about a transverse wave? So a transverse wave, this is a type of a wave whose particles, so you need to understand that in here, whose particles, so particles are vibrating, so whose particles vibrate, so particles vibrate at a what? At a right angle. So particles are vibrating at a right angle or perpendicular. So I want you to understand all these terms that I'm trying to bring out. Or perpendicular. So or perpendicular to the direction of the wave. Direction of the wave. So direction of the what? Wave. This is what we mean when we talk about a transverse wave. So a transverse wave, this is a type of a wave whose particles, so whose particles vibrate at a right angle or perpendicular to the direction of the wave. So each time we are talking about a transverse wave, we are talking about a type of a wave whose particles are able to vibrate at a right angle. You know what we mean when we talk about a right angle. We are talking about a 90 degrees angle. So these are vibrating at a right angle to the direction of the travel of a wave. So the particles and the travel of a wave, they are perpendicular to each other, which means that even as they vibrate, they make a 90 degrees angle. So for example, you've got, this is a base example that we are going to consider like this. So this is a particle, it moves like this. Have you seen? So this is how it is moving like this. So this is a particle moving in this manner. So this is the direction of the wave. This is the what? The direction of a wave. This is the direction of the wave. Then this is a what? This is a particle. So this is a particle that is vibrating. So as you can see, this particle that is vibrating, it is vibrating in that manner. Have you seen? It is vibrating in that manner. So it is vibrating perpendicular to this direction of the wave. So it is vibrating perpendicular to this direction of the wave. This is a particle. So as they are vibrating, they are making a 90 degrees angle. We've got a 90 degrees angle there. We've got a 90 degrees angle there. So this is a best example of a what? This is a best example of a transverse wave. So this is what you need to know. So even as they are vibrating, they are able to vibrate perpendicular to the direction of the travel of a wave. Have you seen? So this particle is able to vibrate, able to do what? Able to vibrate. They are vibrating. So even as they are vibrating, they are making a 90 degrees angle. These particles are doing what? These particles are vibrating. This one like this. This is what you need to, so they are doing what? They are vibrating like this. Here they are vibrating is how they get to do what? To vibrate. They are vibrating. Here they are doing what? They are vibrating. This is what you need to know and understand. So even as they are vibrating, they are making a 90 degrees angle. This is just a base example that can help you revise. So under a transverse wave, we've got certain properties that you need to know and understand. So a good example of a transverse wave, we've got waves on the lobe. So those are examples. So each time we're talking about examples of transverse waves, we've got the waves on a rope. Those are examples. We also have light wave. So all these are examples. I believe I talked about this. We've got also the electromagnetic wave. So apart from this, we also have electromagnetic wave. This is also an example of a what? Of a transverse wave. So this is what you need to get. This is what you need to understand. So certain properties that you are going to find on a transverse wave is that under this we've got this point here, this point on top there. That point is called what? That point is called a crest. Have you seen? You need to understand that point. And this minimum point here is called a trough. Have you seen? So these are things that you need to get and understand. So each time we are talking about a transverse wave, we are talking about, we've got the highest point here, which is called a crest. Then the lowest point here, it is called the what? A trough. So these are properties that you need to understand each time we are talking about a transverse wave. So this was the first one. So we move to the other type of a wave. We move to the other type of a wave. So let us move to the other type of a wave. So we move to the other type of a wave, which will be our 2. Second one. So the second one that you need to talk about is a what? Longitudinal wave. So these are called longitudinal wave. So this is the second type of a wave that you need to understand. It is called a longitudinal wave. So what is a longitudinal wave? What is a longitudinal wave? So a longitudinal wave, this is defined as a type of a wave whose particles, so here I'm going to say whose particles, so whose particles, in here we are talking about particles whose particles vibrate. So particles vibrate parallel. Have you seen? So in here, particles are vibrating parallel to the what? To the direction of the travel of a wave. So direction to the direction of the what? Direction of the travel of a wave. This is what you need to get and understand. So each time you are talking about a longitudinal wave, we are talking about a type of a wave whose particles vibrate parallel to the direction of the wave. So particles are vibrating parallel to the direction of the travel of a wave. This is what you need to get and understand. So, for example, you've got something like this, something that is moving in this. Let's say it is moving like this. Have you seen? They are moving like this. This is a best example. They are moving like this. Have you seen? Like this. This is how they get to move. So this is an example. So in here, the particles get to vibrate like this. Here, these are vibrating like this. At this point, they are vibrating like this. Have you seen? This point, they are vibrating like that. At this point, they are vibrating like this. Have you seen? So this is how they get to vibrate. So this is the point that you need to understand clearly. So even as they are vibrating this one, moving in this manner. Have you seen? So a best example of this one, we've got the waves on a spring. Have you seen? Waves on a what? On a spring. It's a best example. So waves on a spring. We also have the common one, which we all know, which happens to be a sound wave. So these are best examples that we need to consider under a longitudinal wave. So each time we are talking about a longitudinal wave, we also have this point where we've got the particles are compressed, where we've got high pressure. So this point is called compression. Have you seen? So I want you to see this. This is called compression. A part where particles are compressed. Have you seen? A region where particles are compressed. So this type of equation is commonly, they like asking this question in an exam. A point where we've got high pressure in a longitudinal wave. Here where particles are closely, they are close to each other. It is called, this part is called compression. Then this part here, so this part here, where we've got particles, they are spaced like that, they are spaced. So that part is called rarefaction. So that's where we've got the what? We've got even the low pressure. We've got low pressure there. That part is called rarefaction. They are spaced like that. Particles are spaced. Have you seen? So this is what you need to get. This is what you need to understand. So we've talked about two types of waves. We've talked about a longitudinal wave. We've talked about a transverse wave. So make sure you understand this point. Make sure you take note of that. Now, under waves, we've got certain terms that we use, which are called wave terms. We've got certain terms that we get to use each time we are talking about a wave. We've got certain terms that we get to use. So the first term that we are going to start with, so make sure you know all these terms. Make sure you understand them. We've got the amplitude. You need to understand what an amplitude is. So what is amplitude? So amplitude is just defined as, so this is defined as the maximum displacement of a wave from its resting point. So this is a what? Maximum displacement. So this is a maximum displacement. So each time you're talking about amplitude, just talking about the maximum displacement of a particle. So of a what? Of a particle from its resting position, from its resting position. So from its resting what? Resting position. This is what I want you to understand. So this is what? Amplitude. So in an exam, when you are told to define amplitude, how can you define amplitude? You just say that amplitude is the maximum displacement of a particle from its resting position. So this is just a maximum displacement of a particle from its resting point. So the SI unit, whenever you are talking about the SI unit of this, so the SI unit of this, so the unit for amplitude is, unit is what? Meter. You need to understand that it is what? Meter, which is M like that. That is meter. And the symbol for amplitude, so the symbol is what? The symbol is A, just capital letter A. This is the symbol for amplitude, capital letter A. This is the symbol for what? Symbol for amplitude. So this is what you need to know and understand. This is what? Amplitude. The second type that we are going to talk about, so let me love this part. So the second type that we are going to consider, second type that we are going to talk about, so make sure you are able to understand these, they come in your exams. So the second type that we are going to talk about is called wavelength. What is wavelength? You need to understand what wavelength is. So what is wavelength? What is wavelength? So wavelength is a what? So each time we're talking about a wavelength, we are talking about a maximum distance at which a wave repeats itself. So this is a what? A maximum. We are talking about a maximum what? Maximum distance. So this is a maximum distance. This is a maximum distance at which, so at which a wave, at which the wave, so at which the wave repeats, at which a wave repeats itself. Have you seen? Like this. This is what you need to get and understand. So each time you are talking about wavelength, when we are talking about wavelength, we are talking about a what? A maximum distance at which the wave repeats itself. So this is the maximum distance at which the wave gets to repeat itself. So that distance, the maximum distance at which a wave repeats itself, is called a wavelength. Some will say a wavelength is the what? Successive distance between two crests, or the distance between two successive troughs. That's also correct. That's that means that you've defined a wavelength according to transverse wave, because it is only in transverse waves that we get to find crests and troughs, just like that. Have you seen? But this is a general definition of wavelength. This is the maximum distance at which the wave repeats itself. So the maximum distance at which a wave repeats itself is called wavelength. So wavelength, the unit for wavelength, you also need to understand a unit for wavelength. So a unit is what? Unit is meter. Have you seen? This is what? Meter. It is also meter. So it is measured in what? Meter. The symbol for wavelength. So the symbol for wavelength is like that. That's the symbol for wavelength. It is called lambda. Have you seen like this? It is called lambda. This symbol. So what do we call this symbol? This is a what? This is a lambda. Just like that. So now, to give you a short understanding on the two that we've covered so far, I'm going to put down something like this. This is what I'm going to put so that I illustrate what I'm trying to say. Have you seen like this? Something that is moving in this manner. So this is moving like that. So something that is moving in this manner like this. So the distance, we talked about amplitude at first. We talked about amplitude. So you know that this is this point here. This is called a crest. I talked about this. This is called a what? A trough. This is what you understand. I told you this earlier on. So now, whenever we are talking about wavelength, this is a distance between this point. Let's say if we take this point, have you seen this point here, and this point that is here? Have you seen? So when it has started here, it is moving like this. This is how it is moving like this, like this. Have you seen? So when it starts here, it's just the same as it has started again, the way it started here. So that's why we were able to say that wavelength, this is a maximum distance at which a wave repeats itself. So when it starts here, like this, even here it is going to repeat itself. Have you seen? So this point where it is starting to repeat itself, this point from here where it started from to that point, this is what we call what? This is what we call wavelength. This is wavelength. Then we also talked about the amplitude. Amplitude, this is a maximum displacement of a wave from its resting point. So from here to there, this is called what? Amplitude. So like that, amplitude. Even from there to there, have you seen? This is called amplitude. From here resting to there. So when it moves here, it goes on the highest point there. So that point is called what? Amplitude. So amplitude there, that is your amplitude. Here, have you seen? This is how you get to understand this. This is what you need to know. Make sure you understand all these principles that I'm telling you. Make sure you understand them clearly and you get the necessary concept. So the other thing that we are now going to understand is a period. You need to understand what period is. So what is period? What is period? So period of a wave is the time taken for one complete vibration of a particle. Have you seen? This is a what? This one is we get to define as time taken. So I'm going to summarize this. Time taken. This is a time taken for one complete. So one complete vibration of a particle. One complete vibration of a particle. This is what you need to know and understand. So each time you are talking about period, you are just talking about the time taken for one complete vibration of a particle. So one complete vibration of a particle is called the period. So the period of a wave, we define the period of a wave as time taken for one complete vibration of a particle. This is what you need to get. This is what you need to understand. So in other words, period means how long it takes to make one wave. So one wave, you know that from here, when this one gets to move from here like that, moves like in that way. So it gets to move in that direction like this up to that point. So the time it will take for this one wave to be completed, that is what we are calling a period. So I'm saying that period is a time taken for one complete vibration. How long it will take for one wave to be made. So how long will it take for us to make one wave? That is what we are calling period. So make sure you understand this. So the SI unit also, the period has got its own SI unit. So period is the SI unit of period. So the unit for period, unit for what? Unit for period. So the unit for period is seconds. It is what? Seconds. We measure this in seconds. The symbol is T. So the symbol on this is what? The symbol is capital letter T. Make sure you understand this clearly. So this is capital letter what? Capital letter T. That's the symbol that you need to understand. So it is capital letter T. Just capital letter T. This is what you need to get under this one. So this is very simple. You are going to understand this. Then let us move to the other part also. We move to the other part, which is frequency. So we move to the other part, which is frequency. So we are going to talk about this one now, which is frequency. So what is frequency? So frequency of a wave is the number of complete waves produced per second. This is what you need to know and understand. So this is just the number of what? So this is the number of complete waves. Number of complete waves produced. So number of complete waves produced per second. This is what you need to get. So each time you're talking about frequency, this is the number of complete waves produced per second. So the number of complete waves produced per what? Per second. So in other words, frequency is how many waves make in 1 second. So how many waves are we going to make in 1 second? This is frequency. This is the frequency that we are actually talking about. So let's make sure we understand this point, we get everything. So now we've got also the unit for frequency. So the unit for frequency is called Hertz. Have you seen? This is the unit for what? Frequency. Hertz. Then like this, HZ, like this, Hertz. Have you seen? Which means that 1 Hertz. So 1 Hertz is equivalent to what? Is equivalent to this. Have you seen? This is what you need to get. So the symbol for this one is F. The symbol for this one is what? The symbol for this is F. So now there's a relationship between frequency and period. So the frequency and the period is that the relationship that is between frequency and period is that we say frequency is equal to 1 over period. Have you seen? That's why I wrote this one. Is inversely proportional to what? To period. This is what it means. There's a negative 1 there. So this one is inversely proportional. Frequency is inversely proportional to period. And this is the formula that we get to use. So this must be a small letter F. So this is the formula for what? This is the formula for frequency. So let's make sure we understand this point. We get the necessary points that we need to understand. So this is under waves. So make sure you understand this. So now we go to the last one that we are going to talk about. We go to the last one now. We move to the last part. So we move to the last part. So let us move to the last part. So we move to the last part, which is speed. You need to understand what speed is. So what is speed under this? What is speed? So speed of a wave is distance traveled by the wave in 1 second. So whenever you are talking about speed of a wave, this is just a distance. So I want you to understand this. This is just what? This is just a distance traveled. So this is a distance traveled by the wave in 1 second. Have you seen? Just like that. So each time you're talking about speed, this is just a distance traveled by the wave in 1 second. This is what you need to get. This is what you need to understand. So let's make sure we understand this point. We get this point. So the speed, we know that speed, the unit for speed is meter per second. So meter per what? Meter per second. This is the unit for speed, which is just meter per second. Meter per second, like that. This is what? Then the symbol for speed. We all know the symbol for speed. This is what? This is V. This is a symbol for speed. And we have an equation that gets to balance this. We have an equation that gets to balance this, which is speed is equal to frequency times lambda. Obviously, this is the equation that we normally use under waves. This is the equation that you need to understand. This is the equation that you need to make sure that you get it. Have you seen? This is the equation that you need to know. This is speed or velocity. So when you're given speed or velocity, we get to use this one. Have you seen? This is speed, or you can use it as what? Velocity. So speed or velocity is equal to frequency times lambda. Wavelength. Have you seen? So now let us look at an example. Let me give an example here so that we understand properly. So let me give an example here. So you watching this lesson will help you answer exam questions. You are going to understand exam question clearly. So let us now look at an example of this. So we focus on the example. So let's say if 100 waves, so if 100 waves are, produced, if 100 waves are produced in 5 seconds, in 5 what? In 5 seconds. So if 100 waves are produced in 5 seconds, then you are told to calculate frequency. What is frequency? So if 100 waves are produced in what? If 100 waves are produced in 5 seconds, so you know that, okay, the number of waves that are produced here, the number of waves, so we've got the number of waves. The number of waves there, how many? The number of waves there, how many? 100. This is what you need to know. Then we've got the time taken. What is the time taken? What is the time taken? Time taken is 5, like this. This is what you need to understand. So under this, this is just the same as you are doing this. This is what you are doing. So this is just the same as 100 waves. So 100 waves is being produced in 5 seconds. Then we want to find what? We want to find the frequency. This is how you get to find the frequency. Have you seen? This is how you get to find the frequency. So I'm telling you how you can find now the frequency when a question is asked in this manner. If 100 waves are produced in 5 seconds, then find the frequency. So 100 waves are being produced in what? Are being produced in 5 seconds. Then you know that X waves should be produced in what? 1 second. The relationship between frequency and period, hope you know it. So here now you know that these are going to cancel out like that. Then you cross multiply. 1 times 100, we have 100, which is equal to x times 5, we got 5x. We divide both sides by 5. We also divide both sides by 5. This cancelled. So what we are going to remain with is x is equal to, so 5 into that, 5 into 100, it is 20. So you say 20 Hz. Have you seen? So this is the number of what? This is the number of where this is frequency. This is actually frequency. This is how you get to calculate what? Frequency. Have you seen? So if 100 waves are produced in 5 seconds, then what is the frequency? You say, okay, the number of waves are 100, time taken is 5. You say 100 waves, 5 seconds. Then x waves should take what? 1 second. Then you do the calculations. The answer that you are going to find is your what? Is your frequency. This is what you need to understand. Let me give you another example on this. Let me give you another example. I want you to understand this, and I want you to get the concept. So let us look at this example. So a wave source. So a wave source of frequency. So frequency I'm going to write like this. Hope you are going to understand. So I'm just going to write like this. Of frequency 100 Hz. So 100 Hz emits waves of wavelength. So emits waves of wavelength 0.1 meters like this. Have you seen? So a wave source of frequency 100 Hz emits waves. So emits waves of wavelength 0.1 meters like that. Then the first question here is, what is the period? What is the period? What is the period? The other question that we are going to talk about is the speed. What is the speed? So these are two questions that we are going to understand. These are two questions that we are going to answer. So what is the period? What is the period now? So I gave you the definition of a frequency. Say frequency. So I gave you this formula. Frequency is equal to 1 over what? 1 over capital letter T. This is what I told you. This is the frequency. So in this case, we are given the frequency. So you just substitute. Frequency is 100, which is equal to 1 over T. You want to find what? You want to find the T now. So you say 100 times T is what? 100T, which is equal to, so here we cross multiply 1. Then you divide both sides by 100. You also divide both sides by 100. This cancelled. So we are going to have T, which is equal to, so when we divide there, we are going to get 0.001. Then you say seconds. Have you seen? This is the what? This is the period that you are told to calculate. We've used this formula. Have you seen? This is the formula that you need to use when you want to calculate such questions. So make sure you understand this point clearly. So this is how you get to calculate period. So we move to the other question. So what is the what? What is the speed? What is the speed? So you are told to calculate what? You are told to calculate speed. And I told you the formula. Speed is equal to frequency times lambda, which is equal to, what is your frequency? 100 times what is your lambda? We are given this wavelength of 0.1. So this is now equal to, so 100 times 0.1, what are you going to get? So 100 times 0.1, what are you going to get? So actually here on this part here, on this part, this should be 1000. So it should be 1000 hertz, like that. Should be 1000 hertz. So which means that the first question, that answer. So the first question we said frequency was equal to what? So frequency was equal to 1 over period, which was equal to, then we said frequency was what? Frequency, our frequency was the frequency is what? 1000. So we need to say 1000, which is equal to 1 over what? T, like that. So this would be 1000 T, which is equal to 1. Then when you divide both sides by 1000, we also divide this side by 1000. This cancelled, we are going to have like this. So when you divide here, that is the answer that you are forming, like this. Have you seen? Seconds. That's the answer that you are forming. So I made the mistake on this. It was supposed to be 1000. So now we move to the, so this is the answer. Have you seen? This is your answer on that. That's how you're supposed to do it. So we are having 1000. So this is equal to, so you say, what are you going to get now? You say frequency times lambda, like that, which is equal to, so what is your frequency? 1000 times, what is your lambda? 0.1. So when you multiply these two, what answer are you going to get? What answer are you going to get? The answer that you are going to get will be what? 100. So 100 meters per what? Per seconds. This is the answer that you are going to get. So this is how we get to understand the wave motion. So make sure you understand this, you get the necessary concept. So if you are new to this YouTube channel, make sure you subscribe and share with others so that each time I upload a new content, you get to be notified. Thank you so much.